Hi there, in this chapter we will try to study collisions. We'll take some particular cases, so let's start.
Is for momentum, I don't know why they use P, they just do, equals M is for mass and V is for velocity.
First of all, we will try to explain the conservation of linear momentum. Assuming that the object is isolated or the system is isolated, then the sum of the external forces must add up to zero. So, the linear momentum before collision must be equal to the linear momentum after collision. We have two types of collisions. The first, which is elastic, and during elastic collisions, linear momentum and kinetic energy must be conserved. So the initial linear momentum and the final linear momentum of a system must be equal. Assuming that we have two particles, one of them m1 and the other is m2 with the initial velocity v1 and v2. Then after collision, the final velocity for the first particle and the second particle will be v1 prime and v2 prime. Since this collision is elastic, then the kinetic energy of the system must be conserved. While in a non-elastic collision, a part of the kinetic energy of the system will be converted into heat, and due to the deformation of the system itself. After using these two equations, which is the conservation of linear momentum and the conservation of kinetic energy, we will reach these two equations. So let's take these equations and try to study some particular cases. In the first case, we assume that these two particles, m1 and m2, are equal in masses. If we just substitute m1 and m2 with their real masses, this part will go into zero. Similarly, in the second formula. So the remaining part will be 2m over 2m, which will cancel up to 1, and the remaining part will be v1 prime equals to v2. And similarly for the second formula, you can see that this part will go into 0 and this part will be 1. The remaining velocity v2 prime equals to v1. Then after collision, these two particles will exchange their speeds. Let's prove this directly. Here we have two particles with masses m1 equals to 1 kg and m2 equals to 1 kg. This particle is at rest. This particle is moving with a speed of 2 meters per second to the right side. As you can see, after collision, particle 1 is at rest and particle 2 is moving with a speed of 2 meters per second. So as you can see, they exchanged their speed. Now in this case, we changed the velocity of particle 1 and particle 2. So we assume that particle 1 is moving with a speed of 2 meters per second, while particle 2 is moving with a speed of 1 meter per second, both of them along the positive x-axis. Let's see what will happen after collision, knowing that these two particles have the same masses. After collision, as you can see here directly, particle 1 took the speed of particle 2, and the same for particle 2, so they exchanged their speed directly after collision. What will happen if we just provide particle 2 the speed of -1? So this particle is now, in this case, particle 1 is moving along the right side with a speed of 2 meters per second, particle 2 is moving along the left side with a speed of 1 meter per second, Let's see what will happen after collision. So we'll repeat again, slow motion. Both of them exchanged their speed. So initially this one was moving along the right side with a speed of 2, and after collision this particle is moving along the left side with a speed of 1. The minus sign represents the direction. In the second case, we'll assume that V2 equals to 0 and M1 is greater than M2. So we have two particles, one of them is bigger than the other, and this particle is at rest. Since V2 equals to 0, then these two parts will be cancelled out. The remaining part will be M1 minus M2, and since M1 is greater than M2, then this part will be a positive value. So V1 prime appears to be having the same direction as V1, and V2 prime will have the same direction as V1. So these two particles, after collision, will be moving along the same direction. Let's prove this. Here we have the first particle with a mass of 2 kilograms. So one of the particles is bigger than the other, and initially will provide this particle with a speed of 2, and this particle will be assumed at rest. So as you can see in this case, after collision, both particles will be moving along the positive direction.